All right, what's on the bench? I've kind of gotten on a current source kick. In looking for the ideal current source that I wanted, I searched a bunch of current sources just to see what modern equivalents are and stuff. And Keithley has a really modern one that's, a couple $1,000s. Can't afford that one. And the old Keithleys, I can't afford some of those, so I've got a couple of those on order. But I ran across this, and I thought it might be fun to have if I could get it for the right price. Now, ILX Lightwave is a company in Bozeman, Montana, who builds test equipment for laser diodes. And I dealt with that company in the mid-'80s, like 1987, maybe, 80, somewhere around 1987. I was getting laser diodes, and I needed a particular piece of test equipment. And they had something that was close, and I wanted to extend it to do other things as well. So I had them build me a custom piece of equipment to my specifications. And they were a great company to work with. I'll tell you my Bozeman, Montana story before we get started here. I went on one of my trips there to talk about my design and how they were doing. And it's a small little airport, and as the little airplane was landing, I noticed that it was pretty bumpy landing, and it was starting to snow. I could see out the window of the airplane that it was snowing. And when we touched down on the runway, we got to the end and turned around and came back. And by the time we got to the airport, and it was one of those airports where you get out of the airplane and walk over to the terminal, a tiny little airport. And as we got out, there was like half an inch of snow on the ground, right? I went, oh, that's not good. It's kind of cold here, isn't it? And so I went to go get my rental car. And I stood in line at the rental car place, and I got up to the lady. And she looked at me, and she goes, oh, where are you coming from, And I says, California. She goes, oh. And then she looked out the window, and then she looked at me, and she looked out the window, and now there's about an inch of snow on the ground. She looked at me again. She says, I'm going to upgrade you to a Jeep. It's 4-wheel drive. Yes, thank you very much. So I got upgraded to a Jeep, which was great. Anyway, back to ILX. They make this little current source, which is really, really cute. It's kind of limited in its capability, but what it does really, really well. It's a 0 to 200 milliamp current source and 0 to 6 volts. It has a 6-volt compliance. And so it's made for laser diodes. And laser diodes are very finicky, and they blow up easily. So the circuitry is well protected. It turns on slowly. It has limits. It really makes sure that you don't do anything bad, okay? And so it's got a limit, and you can do constant power, we'll talk about constant power to constant current. And then the big knob here to adjust the current. All right, let's look at the back. So in the back, there's a 9-pin DB9 connector here, and that's to hook up to laser diodes that have photodiodes in them for feedback. So this will do the feedback. If you wire in your photodiode back here, you can wire in your laser diode. You can wire in the photodiode into this box also, and it will take that current from the photodiode, and then you can set constant power. And then there's a little adjustment here for the photodiode gain, coarse and fine, or you can just use the output as we're going to do today. All right, so let's go ahead and find a power cord here. And we will turn it on. So it's got this nice, beautiful display on it. And you turn the knob and nothing happens. Okay, and we need to adjust a few things. So you go down here to display limit. This is the maximum that it would ever do. So if you want to protect, let's say we want to protect our LED, we will set the limit here to let's say 45 45 milliamps. And now no matter what we do, if we go to constant current mode, okay, we can't go over 45. So I have an LED here. We'll turn it on here, and then we can output. Oops, it says it's open circuit. So let's make sure that my test leads are in good shape. Yeah, there we go. So you can see, oh, it really, really wants us to have a good connection. So let's try that one again. No? Huh. Are my leads dirty? Let me dip my leads in some alcohol here and see if I can clean off any goo. Oh, I didn't have it plugged into the back. Well, that would do it, wouldn't it? It is open circuit. I thought I'd plugged it in, but I guess I didn't. All right, so here we go. We will turn the little button on. Go. There we go. And there it went. It ramped up to 40. Okay, and then we can change it. And 16. So if it ever goes open circuit like we just saw, even for a brief second, it will say, oh, nope, something happened. I don't like it. And then you push the button again. It's kind of a momentary button, and their button's a little flaky, so I maybe need to clean the button. But yeah, we get the LED on, and now we can set it to something like 20 milliamps and test our devices. We can go here again, check the voltage current compliance is still 45. This is constant current mode. And there you see it took a while for it to ramp up, and so it's protecting it. So anyway, so it's a nice little box. And I want to see inside. So I got the box for $85, which I think is a good deal. Yeah, so let's go ahead and short out the leads. And there we go, 20. And let's see if we can go up to. And now I keep going. See, it's current limited by the limit that we set. So I'm going to set the limit all the way high, and we can get 985.5 milliamps out of the thing. Yeah, so there you go. Yeah, it's a foolproof little box. Great for what it does. It only does what it does, but it does it really, really well. So let's open it up, take a look inside. All right, here we go. It took a while to figure out how to open it up, but yes, indeed, we have a front panel board, and then that goes ribbon cabled over to the main board. Looks like there's a nice power supply in a sealed power supply here, and the back solders in. All right, let's flip it around here and kind of get down what's going on down here. Let's see, there's a 7107. I think that's just a display chip. It's basically a DVM on a chip that runs the display. And DG212, that's a FET switch. An OP07, probably for the photodiode or something like that, or maybe just monitoring the current. OP07. Okay, so they like the OP07s. 1, 2, 3, 4. Yeah, OP07s everywhere, so use the good stuff. And LM, I can't read that one in there. What is he? LM339, so comparator there, see if you're too high or too low. That's probably the limit for the limit button in the front as a comparator. A couple things on heat sinks, probably, yeah, 3-terminal regulators, 5-volt regulator there. In the back, we have, I can't read it. Line 12, maybe 12 volt, probably plus minus 12 for the. And another 12 volt over here, yeah. So separate the analog and the digital. Not a lot going on, pretty clean. Let's see what date codes we have here. Oh, what's that chip there? I didn't really look at that chip. Oh, Bird Brown. Oh, what is he? Oh, I can't really read him. Gotta be good stuff, right? An INA 101. So that's like a instrumentation amplifier. And a bunch of adjustments. Nice. Yeah, I like it. Date codes. Let's see what date codes we got here. Everything is so small, I can't read today. 1990 maybe? 90, what's this one say? 97. 1997. What's this thing over here say? 98. And an LS112. Huh. 1998. Yeah, so around 1998, 1999. Looks pretty good to me. Yeah, let's see if I can get it back together. Okie dokie. That switch on the front panel was flaky, so I'm going to rebuild this switch. There's definitely something wrong with it. So I've taken it apart here, and hopefully I can clean all the contacts. It's got these little wiper contacts. Put it all back together, so hopefully that'll make it better. All right, well, there you go. I failed at repairing this switch, but I did find one in my junk bin and put that in here. So now it operates very smoothly now. Before it was kind of intermittent. And yeah, see, on, off, on, ramp up, good, off. So new switch is good. So it's all back together and working better than it came in the door. So there we go. That's my new acquisition, the ILX Lightwave LDX-3412.